Hello viewers, here we are with the Kenmore dehumidifier again. Whirlpool manufactured, Kenmore branded. Here is the information, and there's the serial number from which you can derive the date of manufacture, which I have confirmed on two different sources that this would have been manufactured in March of 1993. So, what I want to do today is do a brief service on this, because I'm going to give a test run this weekend. And we're not going to do a full clean and service because I don't have a use case for this right now, and I may not for a very long time. So I'm not going to take this outside in 23-degree weather and try to clean the coils and everything. So I'll do that in the summer, which is when a use case is probably going to arise. Now, there have been in the past moisture issues in this room during the winter. When or if that happens, then we'll have to clean and service this and probably use it here in the shop. That may not happen. It doesn't always happen. Thus far it hasn't happened, and it's been plenty cold. So I don't know. I don't really understand what the conditions are to, just happen so perfectly to make the pipes leak. Sometimes it happens, sometimes it doesn't. Thus far we've been okay. Anyways, so what I want to do is primarily just lubricate the fan motor, because the fan motor is the primary point of failure in these machines, and so I don't want to do anything to the fan motor that would inhibit premature failure, such as running it without any lubrication. So these are extremely easy to service because they were designed to be serviced. There's two screws under the bottom of the cage here. They are common, or I don't know what size bolt it is. This is what they look like. And they are machine screws. And there's just two of them. Okay, so with that removed, whoops, wrong zooming. I'm going to pull off the knob. I'm going to pull up and away. And that's it. We now have complete access to the machine. So this is dusty. It needs to be cleaned, but I'm not going to clean it right now. The compressor is also dusty, and that needs to be cleaned, but I'm not going to clean it right now. There has been some debate about this being as new as 1993. This is another piece of evidence that it's of relatively recent manufacture. This is a pretty modern style start and run capacitor and relay box. And here's the compressor information itself. It is made in Brazil. Let's see if we get that a little bit more readable. It is I don't know, is it doesn't say what kind of refrigerant it is, but I know it's R500 as described on the back. So anyways, the fan is an Emerson fan, and it is model, I really can't tell, it's too dirty, model F33AMJSJ-4199, made in Korea. Looks like 1/100th of the horsepower. I'm not sure. It seems awfully weak. Yeah, it says 1/100th horsepower. So anyways, the motor does in fact have two oil ports on it, one there and one there. And again, the fan is very dirty. It needs to be cleaned. Actually, the spin down time is not bad at all. I do think this is probably a lower hours machine. Anyways, I'm going to put the camera back onto the tripod now, and we're going to get some oil out We're going to use fan oil as we go through in most of these videos. This is the kind of oil that goes in fan bearings. It even has a picture of a fan on the back of it because that's what it's for. And I'm going to take this fan oil and I'm going to put a few drops into each of those oil ports on the motor. And again, when the time comes that this is going to get assigned a use case, I will probably take the fan motor and split it apart and clean the bearings. Or actually, I may not do that unless it's absolutely necessary, because unless it unscrews from the front, it looks like it's kind of pressed together, which is not going to be easy to take apart. So here's the fan oil, and I'm going to put a couple drops into each hole. And they don't seem to be working too well. Not sure what the problem is here. Well, maybe we're going to have to split it open anyways. Well, maybe that is working. It looks like it improved a little bit. Alright, let's do the front bearing. Admittedly, this is a little bit awkward to access. Yeah, it's leaking again. I'm not really satisfied with the amount of oil that got into the front bearing. Having immense difficulties here getting the oil can to be at the right angle. I'm not ecstatic about the spin down time of that fan, but it's going to suffice for now. The test run is probably only going to durate maybe an hour and a half. So if it's not in absolutely flawless condition, it shouldn't be an issue. It's going to be fine to run now. It's definitely spinning freely, and that was really the major concern. So now that we have it open, we'll be able to get a better startup sound, a running sound of the compressor. So this should be off. I'm going to plug it into the meter here because I don't think I put a meter on this yet. And I want to make sure the power draw is normal and everything is checking out okay. I believe this is rated for 5.9 amps. So I'm going to take the camera off and put this down here, and we should be able to get a good startup sound this time because the fan will just be drafting up. It won't be drafting down by the compressor. So here we go. I'm going to start it up now. compressor is nearly inaudible. That's going to show up 5.2 amps. Should be going up as the head pressure builds, which it seems to be doing so. The fan is still drafting down the bottom very much. That probably ruined my startup sound. Oh well. Up to 5.52 amps. We're testing at 121 volts. Up to 5.7 amps. Now back down to 5.5. I think this meter is a little bit flaky. Gave some cuckoo readings when I was using it for the Christmas lights, so I think it's okay now. It's saying 5.5. The compressor is so quiet on this machine. And it doesn't feel like it's very heated or cooled. The air is pretty much room temperature coming out of there. Be able to get a measure of the condenser with the fan blades in the way. It's reading about 75. Oh jeez, that's the service port. I'm measuring this and saying, why the heck isn't it going up? That's not the discharge. The discharge is over here. About 100. Pretty stable at 5.55 amps. Of course, that's for it to believe this meter. I think this meter is a little bit flaky. But anyways, that's right around where it should be. This charge is reading as 108. This machine is R500, which is a good refrigerant. Much better than what we have now, or it's 410 junk or whatever. But I don't think it's as good as R22. It doesn't seem to get as hot or as cold. Up to 111 now. And I can feel it's starting to get a little warm. 77 is the surface of the blades. Motor's 85. Compressor is 81. Let's turn this around and see if we can get a reading of the evaporator. And I don't want to leave this running for too long because I don't want it to start dripping water. It should only take maybe 10 or 15 minutes to start dripping water. Although, probably not that humid in here. The coil does need to be cleaned. It's not awful, but it really should be cleaned. You can see we got plenty of water condensating on the machine already. just remove this. I think this can be removed. I may just remove that for the test because I want to have the camera on the coils and be able to see the water dripping out of there. It's definitely getting cold. It's in the 40s. But if this was an R22, I think it could get well below 40. Although then again, with a machine like this, you don't want it to get too cold because you'll get ice. And since this is intended to be used in basements and other areas that aren't really warm, you don't necessarily want it to get that cold either, just cold enough to condensate. See where the it must come into the top because the top is much colder. But I don't see. It looks like it comes in over there. I don't know. It's definitely working, and it's certainly sweating pretty good already. I guess it is probably better for this kind of machine to remain up in the 40s, high 40s, 50s, because it won't ice up. I think that's good enough. Let's turn it off now. Turn it back around so we can see the spin down time on the fan. And we're still at 5.55 amps. The spin down time on the fan kind of stinks. But it is just a light plastic coating, maybe it's okay. Listen to the refrigerant flow. See the water drops condensating on there. And just for purposes of curiosity, let me get a reading on the humidity in here. It is. It's only 37%. I don't know if that gauge is necessarily calibrated correctly, but that gauge is reading 37% in here, which is quite low. So if it's getting this much condensation on there with only 37% in the air, it should work all the better if there's more in the air. I tend to believe that gauge because it's winter, it's relatively cold today, the heater's been on a lot, so the air is probably dry. So, yeah, that's a good amount of water on there. So, next video, we will get to see this thing in action. And I'm going to have to come up with something to collect the water, probably just get some kind of a square plastic bin or something to collect it with.